All right, so we're going to look at some more cross-section volumes today. And so yesterday or the previous lesson, we were looking at the integral from a to b of a of x dx. And this was where a of x is the area of whatever given shape you have, is the area of the given shape. All right, so what do we mean by given shape? If you look at the next example down here, this time we're looking at not such a nice neat little base here, but it really doesn't matter because it talks about the volume of the solid again, whose base is given in the region R. All right, so our solid over here is this area in the shaded region here, and our cross sections are going to be perpendicular to the y-axis, and they're semicircles. So yesterday we were drawing everything perpendicular to the x-axis. Today we're going to be drawing perpendicular to the y-axis. So if you can picture the cross section going this direction, and now all these little cross sections are semicircles just like that. Okay, so really the only difference here today is the fact that because we're going perpendicular to the y-axis, our integral here, since make a little note here, perpendicular to the y-axis. So what that implies is that and it says it right there, our slice is perpendicular, so we're going to be integrating from a to b of, and since these are semicircles, it's going to be 1/2 pi r squared, and then it's going to be dy instead of dx here. And again, the reason is because we're perpendicular to the y-axis. You guys saw this before when we did this with area between curves and that kind of thing. So in this case, we're going to be looking at a right minus left situation. Okay, that's going to be the base of our shape. Okay. All right, so we're going to start off. We're going to need to do some other things here first as well. I may need to shrink my page here, but we've got, we need to know what our limits of integration here are. And our two shapes are crossing somewhere up in this area towards the top of the graph. The bottom one is just going to be 0. You can see our two equations here, but before I can set up an integral, my upper limit, I need to find out where that point of intersection is. And so that's the first thing I'm going to do. I'm going to find the intersection. And I'm going to do that simply by setting the two equations equal to each other. So I have x squared equals 4x. If we subtract 4x, we get x squared minus 4x equal to 0. And we'll get x times x minus 4 equal to 0. So we have our intersection. There's our first one at 0, which was the one we already knew about. And then our second one's going to be at x equals positive 4. Now that's not my limit of integration because that's the x value there, and I need to know the y value. So the y value is going to equal y equals, and I can use either equation here, and that's going to be y equals 4 squared, which is equal to 16. All right, so somewhere it looks right up in here. So I'm just going to put 16 right here, and so those are my limits for my integration. All right, so that's the first part of that I need. The second part is I need to find out what r is, because again, I need the formula for area equals 1/2 pi r squared, and so my r value is going to be half of the base again. Okay, half of the diameter of that circle, where the diameter is the right minus the left. So we need to do a little bit of right minus left again. Okay, so I'm going to call this the base of the circle again. This is going to be base, and we've got y equals x squared. Okay, so before I can do anything with that, I've got to, because everything's perpendicular to the y-axis, I've got to solve this for x. So this is going to be plus and minus the square root of y equals x. But since we're on the positive side of the y-axis, I need the positive square root here. So that's going to be my first equation there, and that is my right-hand side equation. Okay, so this is right. And now we'll do left here. And so our left is going to be y equals 4x. And again, we have to solve this for x. So y over 4 is going to equal x. And this is the left side of that shape. And now we need to actually do right minus left to find the whole base. All right. So right minus left. So we're going to end up with the square root of y minus y over 4. That'll be a fun one, won't it? It's a good thing we have calculators, huh? And again, this is our base or our diameter here. Now it's important that you understand that because I still need to cut that in half. So I need the radius. So r is going to equal 1/2 of the square root of y minus y over 4. All right? And so our radius is going to be square root of y divided by 2 minus y over 8. All right? All that just to set up our integral. So now that we have that, we can actually set up the integral. So our integral is going to be from 0 to, what did we say, 16 up at the top. This is going to be, and again, I'm just going to write out the formula. Well, you got the formula at the top. It's 1/2 pi r squared. So I need 1/2 times pi times r squared. Now r is all of this mess over here. So this is the square root of y over 2 minus y over 8. And that whole thing is the radius. So we need to square that with respect to y here. Okay? Now, again, this is just calculator stuff here. So I would encourage you to take out your calculator and pop this in. And you should end up with 3.351. Okay? All right. Now, if you look at this next one, it starts off and it's a little confusing at first because it talks about the volume being the same solid as we have on the left side. Okay, so same picture that we used on the left. And let's see, and it's whose cross sections perpendicular to the x-axis are given by the formula a of x equals. So if you don't read this carefully, which I didn't the first time, I'm looking at this trying to figure out how do I draw this figure onto that shape. But what you'll notice here is that they give you the area function. And again, our area function is given right up here at the top. We need the integral from a to b of the area function dx. Okay, so because we are doing this and we're going perpendicular to the x-axis this time, I need the oops, we don't want that one. We want the integral. This time our limits are with respect to x, so we're going to be from 0 to 4. And our area function is already given to us. It's cosine of, what do we got here? Pi over 8 times x dx. Okay, so we don't have to worry about an upper minus a lower and all that kind of stuff. They're just basically saying, look, here's your area function. Okay, this is it. So all we have to do is plug this into a calculator, or we could probably even integrate this one. Oh, this one says no calculator right here. So we need to integrate this by hand. So we're going to take the antiderivative of cosine, which is sine pi over 8 times x. But if we were to take the derivative of that, we would get a pi 8ths there. So we need to multiply by 8 over pi. All right. And we are going from 0 to 4 here. So let's plug in and see what we got here. We're going to get 8 over pi times the sine of pi 8ths times 4 minus 8 over pi times the sine of pi over 8 times 0. And by the way, if I already knew that that right hand side was going to be 0, I really didn't even need to do any of this because the sine of 0 is 0, so this whole side is going to cancel out. On the right side here, I'm going to get 8 over pi times the sine of pi halves, and the sine of pi halves is 1, and 1 times 8 over pi is just 8 over pi. Alright, so easier than it looks sometimes. Alright, so that's all there is to this lesson. Just a little short one today. We'll do some practice together. Okay, so number 9 on the homework, page 273. We're going to look at this one. We have a circle with a radius of 1, and it says we are going to go perpendicular to the x-axis, and our base and height are equal. And I missed the part, base and height, these are triangles. Okay, so these are triangles where the base and height are equal. So if I were to draw a triangle in here, okay, so I'm going to come across here, and I'm just going to do the best I can. Base and height are equal. All right, so here's the height of my triangle coming down just like this. So the base and the height are the same. Now, again, if you look at this, I need to do some upper minus lower here again. Okay, in order to find the base of this triangle, I need to do upper minus lower. Well, the upper part, again, to do this, we're going to need to solve this thing for y. Okay, so x squared plus y squared equal to 1. If we subtract x squared, we get y squared equals 1 minus x squared. Hopefully this looks familiar from what we did on the other problem. If we square root both sides, we get the positive and the negative root of 1 minus x squared. So the positive root is our upper, the negative root is our lower, and so when we do upper minus lower, okay, this is going to be our base of that triangle. This is going to be the positive root again, so 1 minus x squared, minus the negative root, 1 minus x squared. And those two are, you're going to end up adding them together, and we're going to end up with 2 times the square root of 1 minus x squared. Okay, so when I go to put this together now for my integral, I think I got enough room here. We're going to do the integral. This time our limits are 1 to negative 1, or excuse me, negative 1 to 1, because our circle only has a radius of 1. So we would go negative 1 to 1. The formula for the area of a triangle. So again, we want to always make sure we know what is our formula for the shape that we're dealing with. In this case, because we know that the base and the height are equal, we can say that this is 1/2 base times height, but really the base and the height, again, since they're equal, is 1/2 base times base, if you want to call it that. So we have 1/2, and the upper minus the lower here, this is my base. So I'm going to do 1/2 times 2 square root of 1 minus x squared times the height, which is also going to be 2 times the square root of 1 minus x squared with respect to x, so dx. Okay, and if you pop this in your calculator, and again I would encourage you to do this, you're going to end up with 2.667. If you crank this all out by hand here, you will actually end up with 8/3. Okay, so this one you could actually crank it out by hand if you wanted to. All right. Okay, so number 10 on the same page here, same homework assignment. So we've got, this time we have the base is a triangle formed by the equation x plus y equals 1. All right, so the first thing I would want to do is graph that, and it's formed by that equation, the x-axis, the y-axis, and we're doing semicircles perpendicular to the y-axis. All right, so if I'm going to graph x plus y equal to 1, I would probably just solve for y, so this would be y equals negative x plus 1. All right, so I'm going to go up here to 1 on the y-axis, and negative x is just a slope of 1 to 1. So I'm going to come down to the x-axis at positive 1. And so there's my picture. So there's my triangle formed by those three parts. And then I have semicircles that are perpendicular to the y-axis. So this time again we're going this direction. So we're going to need a right minus left. And again, if you could picture, some semicircles are going to form that shape. Now I didn't draw it very three-dimensional here, but that's basically what you're looking at is a bunch of those little half circles there. So I need to find the base. Again, if you think about this, our integral needs to be the integral from, we're going to go on the y-axis here, since we're perpendicular to the y, so we're going to be going from 0 to 1. These are semicircles, and again, the base on this semicircle is the distance of our right minus left. So we're going to need to do that. We're going to need to do a little bit of right minus left here. Okay, so we got right and left. So right minus left. Our right side is the function x plus y equals 1, but since we're perpendicular to the y-axis, now I need this equation solved for x. So x plus y equals 1. If I solve for x, I get x equals negative y plus 1, or 1 minus y might even be easier on this one. So the right side of this is going to be negative y plus 1 minus the left side, which is just 0. So hopefully that one was kind of obvious. And this is just going to be negative y plus 1 as our base. Okay, so my integral now again goes from 0 to 1. The area, let's see, we need 0 to 1 of a of x. Or excuse me, in this case, we're doing a of y dy. So I need the area. So now that I've got the base, okay, right minus left gives me the base. I need half of that base for the area, because we're looking at 1/2 pi r squared again for a of y. 1/2 pi r squared. So our r value, r is going to equal half of this guy, so that's going to be, what do we got? You know what, since we're going to pop this in the calculator, yeah, we're just going to pop this in anyway, so I'm just going to put negative y plus 1 all over 2. I'm not going to bother splitting it up. All right, so going back to our integral, let's see if we can set this up. 0 to 1 of 1/2 times pi times the radius, which is negative y plus 1, divided by 2, that whole thing being squared, and this time dy. All right, so you can pop this into your calculator again, just like you would with any other x's, and it turns out that this is 0.131. Interesting. Very small volume there. Okay, all right, so there's number 10. Let me set up the next one. Okay, so here's our picture set up on this one. The base is a semicircle this time. It's given by the equation y equals 9, square root of 9 minus x squared, so that's the upper half of a circle. It wouldn't really matter if you use the lower half on this one. Our limits are negative 3 to 3. Again, that's the radius of that circle. We're going perpendicular to the x-axis, so I'm going to be this direction here. And my shapes are going to be squares. So again, I didn't do a great job of drawing this, but I'm going to do the best I can to draw a square here. If I were to put squares on here, it might look something like, I don't even know how I'm going to get this done. Oh boy. All right, let me try this. So a square. Yeah, that's not too bad. So our shapes are going to be squares. So we need to take the integral from negative 3 to 3 of the area of a square. So that's going to be side squared. Since we're going perpendicular to the x-axis, it's going to be with respect to x. So we need to find the length of the side of a square. And in order to do that, again, we're going to do some upper minus lower. Now, hopefully the upper minus lower, because we're sitting on the x-axis, the lower is just 0. So the upper is simply our function here. The upper is going to equal the square root of 9 minus x squared. All right, so that's the length of our side. Since they're squares, we're just going to square that. So this becomes the integral from -3 to 3 of the square root of 9 minus x squared dx. And you know what? We'll go ahead and do this one by hand because this one's pretty straightforward and easy. This is going to equal -3 to 3 of 9 minus x squared dx. So if we take the antiderivative, we get 9x minus x cubed over 3 from -3 to 3. And so we're going to end up with 9 times 3 minus 3 cubed over 3 minus 9 times -3 minus -3 cubed over 3. All right, we've done this one a few times. This is 27 minus 9 minus -27, and then plus 9 here. And if you add all that up, if you add all that up, you're going to get 36. All right, that one wasn't so bad, was it? That one was pretty easy, I think. Okay, so number 13 says we have a base region enclosed by y equals x squared. So I've got this guy coming up like this on both sides. All right. Ooh, boy, that left side's terrible. Let's try and get it at least close to being even, right? All right, that's a little better. Let me see. Y equals 3. So that's going to be the top part of our function here. So this is y equals 3. We're perpendicular to the y-axis and we're doing squares. So our squares are going to be perpendicular to the y-axis, just like this. And I know that's not a square, but we know it's a square. Okay, there we go. All right, so we're going to need, let me see, what do we need to know here? We need to know our limits of integration. Since we're perpendicular to the y-axis, it's going to go from 0 to 3. So we've got our limits for integration. We need our right minus left in this case. So right and left, that's going to be the base of our square. So we're going to be doing the integral of s squared dy from 0 to 3. Okay, all right, so in order to find the base of this, we need to do a right minus left. Since our equation is y equals x squared, we're going to have to mess with that a little bit. This is going to be y equals x squared. We need to get x by itself. So x is going to equal the positive and the negative square root of y. So my right side, if we look at right minus left, all right, my right side is going to be the positive square root of y minus the negative square root of y, which is going to be plus, and so our base is going to be 2 times the square root of y. Boy, that was pretty straightforward there, wasn't it? That wasn't so bad. Okay, so setting up my integral now, it's just going to be the integral from 0 to 3. That is our base, so we have 2 times the square root of y. We're going to square that with respect to y. And we can probably crank this one out by hand too. 0 to 3 of, oops, no. 0 to 3 of 4 times y dy. If we take the antiderivative, we get 2y squared. That's it, 2y squared, isn't it? From 0 to 3. Boy, this thing's turning out much easier. 2y squared from 0 to 3. So we've got 2 times 3 squared minus 0. The right side's going to be 0. So that's going to be 18. All right, and there you go. Okay, so here's our last one. I just used the picture from up top. And so we've got basically rectangles this time, perpendicular to the y-axis, same equation, same restrictions on our integral 0 to 3. But now the height of the rectangles is y cubed. Okay, so it's an interesting little picture here, but we already know that this base, because we found that out in the last one, is going to be, the base is 2 square root y. All right, we did that work in number 13. So we're going to look at the integral from 0 to 3 of, I don't know why this is doing that. All right, 0 to 3 of, let me get this guy off here. There we go. 0 to 3 base 2 times the square root of y times the height, that's y cubed. This is with respect to y in this case. All right. Let's see. This is probably some good practice with exponents here. So we're going to simplify this. We know that the square root of y is just y to the 1/2. If I multiply y to the 1/2 times y to the 3rd, I add the exponents. That's y to the 3½ power. So we're going to actually end up with 2 times y to the 7/2 power dy. All right, we're still going from 0 to 3. If I take the antiderivative of that, I'm going to have, let me see, I've got 2 times y. I need to add 1 to the exponent. That's going to be 9/2. But then we're going to have to multiply this by 2/9. And we're going from 0 to 3 here. All right, so plugging in 3, we've got 4/9 times 3 to the 9/2 minus 0, and we would definitely have to get out a calculator for that, and I don't have one in front of me right now, so I'm not quite sure what that equals. All right, so I'll let you guys pop that into your calculator, but that's basically it for those questions there. All right, see you next time.